Okay, so we've been talking about our ratios and proportions and percents. Today I want to talk a little bit about some of the applications for them. We've talked about some of them. We talked about gear ratios and pulley ratios and roof slopes and pitches and stuff like that. Talked about grades. But we can now use, now that we know how to use the proportions, we can use these proportions to find those missing pieces. For example, if we have a pulley ratio here, or if we have a pulley system, and we need to have a ratio of 5 to 2. And say the motor, of course, is hooked to the smaller one in this case. Let's say we have a pulley on the motor that is 6 inches in diameter. What diameter does the other pulley have to be? Well, 5 to 2. Of course, the driving is the bottom number. That's the one hooked to the motor. So that would be the 6 inches. Cross, multiply, and divide. You get 15 inches is the diameter of that pulley. We've seen it with our roof slopes. If we have a 42-foot span on an 812 roof, we can find the height of that roof by using that 812 ratio. What's going to go over here? 21 goes on bottom because we're looking at the run, not the full span. And on top is just H. That's what we're looking for. So we cross multiply. 8 times 21 divided by 12 is 14. So it'll be 14 feet tall. Nice try, though. Well, we can have more complex ratios. Let's say that you have a ratio of lengths that end up being 4 feet 3 inches to 1 foot 5 inch. Well, as it's written right now, it is not a ratio. To be a true ratio, we must have two numbers, each with a single unit, and they must have the same unit. So what we would do here is convert each of these into just inches. So that top number is going to become how many inches? 51. 4 times 12 is 48, plus 3 is 51 inches. The bottom will be 17. 12 plus 5 is 17. And now, of course, we can simplify that. The inches will cancel out. I'll do that for you. What can the rest of those, each of those others be reduced by? You'll both be divided by 17. It's a 3 to 1 ratio. So it'd be written as 3 over 1 or 3 to 1 like that. We can also have ratios that involve more than one number. If you're looking at concrete, concrete has 3 ingredients. It has the cement, the Portland cement. It has sand. And it has aggregate. Of course, it also has water, but we're not worried about that right now. Most concrete is a 1 to 2 to 5 ratio. 1 part cement for every 2 parts sand to 5 parts aggregate. Now the problem with dealing with a ratio like this that's a 3-part ratio is doing stuff with it is very difficult because I can't just relate 2 items. Let's say that I need to make 8 cubic yards of concrete. I need to know how much of each ingredient to use. Well, the first thing I would do if I was mixing this myself is I would convert cubic yards into cubic feet. Most of the ingredients, cement, especially if a bag cement comes in either 1 cubic foot bags or 1/2 cubic foot bags. Do you know how you can tell? 1 cubic foot is usually about 100 pounds. So if it's a 50-pound bag, it's a 1/2 cubic foot. If it's a 100-pound bag, it's a full cubic foot. So anyway, 8 cubic yards, how am I going to convert that into cubic feet? Times, how many feet are in a yard? Yeah, 27 cubic feet in a cubic yard. Good. 3 feet in a yard, and it's 3 cubes. So 3 divided 3 times 3. So 8 times 27 is 216 cubic feet. Well, how are we going to use the 1 to 2 to 5 ratio? To use it, when we have a 3-part ratio like that, we find a total. What's 1 plus 2 plus 5? 8. So then what we do is we use a ratio of each ingredient to the total mix. So cement is now 1 to 8, 1/8 of the total mix. The sand is now 2/8 of the total mix, or 1/4. And the aggregate is 5/8 of the total mix, or the rock is 5/8. So then we can find now the amount of cement, Portland cement, will be 1 to 8, will be blank out of 216 cubic feet is the total mix. If you cross multiply and divide, you get 27 cubic feet of cement. The sand will be 2/8. So 2 to 8, if you cross multiply and divide there, you're going to get 54 cubic feet. And then, of course, 5/8 for the aggregate. Cross multiply and divide there, you should end up with 135 cubic feet. And if you add those all together, you better come up with the 216. I hope. You will. Any questions? So, yeah. So whenever you have a 3-part ratio, usually the easier way to look at it is to add all the parts together to get a total, and then convert it so that each of them is a fraction of the total rather than just relating the parts. It's still the same ratio. 1 to 2 to 5 is the same as 1/8 to 2/8 to 5/8. It's just in this form, then you can use the fraction to find what is the ratio of each to the whole amount. Colt will understand this next one. In masonry, if you're looking to mix brick or block mortar, that actually has 4 ingredients, depending on the type of mortar. If you have a type M mortar, you have the Portland cement. It actually has lime in it. Then you have sand and water. Mortar doesn't have aggregate, doesn't have stone in it, it just has sand. The lime kind of replaces the aggregate in the mortar. So if you're looking at type M, do you remember all these, Colt?
Type M, type O, type S.
Yep. M, N, and OS, yep. Remember which one is M? Yeah. M is underground, 4 parts Portland to 1 part lime, or 1 part Portland to 1/4 part lime. It's mixed out. It's heavy with the Portland cement is very expensive, but it's very, very strong. It's mixed that way because lime tends to leach out of the mortar if it's exposed. If it's underground, the ground will actually suck the lime out of the mix. So you don't put as much in. Type S. 2 parts Portland to 1 part lime. This is if you have a heavy structural application. So it's going to be supporting a lot of weight, really tall building, stuff like that. Type N is 1 to 1. This is the all-purpose mortar. This is what's usually used for doing block work. You never use it? What do you use?
S.
Type S. It's a little bit stronger. Yeah. It's just more expensive. Portland is pricey, and there have been issues in the past. About 7 or 8 years ago, there was a while where they were actually restricting Portland cement. They were only allowing like ready mix plants to have like 1 semi-load a week of Portland. So then there's type O, which is a 1 to 2. It's high in lime. This is made for decorative applications like a brick face. You have the block wall has the stronger mortar. They just have a brick face on the wall. Use type O just because it's cheaper. The only problem with type O is if it's exposed to the weather. Like I said, lime leaches out as exposure to water, and wetting and drying cycles will leach the lime out. That you have to re-chink because it can cause issues. There can be pores. It really cause cavities in the mortar. Notice I didn't do the sand yet. The sand depending on where you look, is anywhere from 2 1/4 to 3 times the other solids. What does that mean? Well, let's say you're mixing a type S mortar, and you're going to have 8 parts Portland. How many parts of lime are you going to have? It's 2 to 1, so how many parts of lime? The Portland is 2, the lime is 1, so 8 to 4. Half as much, right? So that means for the sand now, you have 12 total parts here. So the amount of sand is 2 1/4, or is it 2 1/4? Should be 2 1/4, not 2 1/2. 2 1/4 to 3 times. So 12 times 2 1/4 is 27. 12 times 3 is 36. So it'd be anywhere from 27 to 36 parts of sand, depending on how you wanted it mixed. Tomorrow in class, we're going to look at a packet that's actually made for masonry. We'll actually go over more specifics on doing the mixtures. For right now, I'm going to give you a packet. In this packet, it'll be pages 95 through 106. This is going to be another one that's the gray boxes again.